So here is another of our example. Obviously, we can already see that this is in form of a quadratic equation. So how do we go about solving it? Because these are actually different. Well, we can't solve an equation with different variables. Okay. Unless if there are multiple equations, but this is just one. So how do we solve this? So we have to align, simplify it to one variable. So we can choose to make it sine, or we can choose to make it cosine. But making it cosine means that we're just going to introduce a half angle here. So we don't want to do that. So the best is to replace this one. Now remember, we have that Pythagorean identity that we can use to replace this. So we can say 2, okay, 1 minus sine squared x, like that, plus 3 sine x minus 3 equal to 0. Now we go on and expand. You see, all of mathematics is just about what? Simplification. If you know how to simplify equations at all, then you are going to be very good at maths. Okay, so we see that we've got like terms here. We can actually already simplify that. So this is negative, that's positive, meaning that we're going to have a negative outcome. The outcome difference between 2 and 3 is 1, so negative. So we continue. Here we're going to say 2 sine squared x plus 3x, 3 sine x rather, then minus 1 is equal to 0. But we don't want to solve it like this. So we're going to multiply this whole equation by negative 1. So this is going to be 2 sine squared x, right? Then plus, actually minus 3 sine x plus 1 equal to 0. Now we are at the stage where we can solve. Now this can be solved in two ways. You can replace this with a variable, another variable. Let's say we say p is equal to sine x, or we can even say y is equal to sine x, or whichever you prefer. But I think for me, it's simple enough for me to just continue and solve like this. I only replace when I think that it's complicated. So 2 by 1, that's 2. Then we know that the sum is minus 3. So we're going to have 2 sine x here, then minus sine x, which is 1, plus 1 equal to 0. So this is easy to see, visualize, there's no problem here. So we can have sine x here, right? Then we have sine x remaining here, minus 1. Then here, minus 1 again. Then here we'll have sine x, minus 1 equals to 0. Okay, so we'll have two factors here, 2 sine x minus 1, right? And then we'll have sine x minus 1, like that, is equal to 0. So we can say that our equations are resolving into these two factors. So we can say that sine x has got two values, is equal to 1 over 2, which is from here, and then the same sine x is equal to 1. Okay, so now I'm forgetting to write this. The domain here is going to be the domain is going to be 0, like that, x, like that, 2 pi. So that's up to 360. So that's our domain. So we're looking for those solutions. Now, we know that from our special angles, we know that sine x, sine half x, okay, sine half x gives us pi over 6. Okay, it gives us pi over 6. So pi over 6. So we can say x is equal to pi over 6. That's the first one. But then that's not the end, because we can still check and say this one, we got it from here. Okay, the reference angle was pi over 6. And so the angle itself is pi over 6. Then we go to the next one. We check our ASTC. So we're dealing with that guy there. Okay, sine. So we're going to say that we're looking for the answer here. Okay, so we're just going to draw it. Then we use our reference angle, which is this one here, pi over 6, to get our theta or our x here. Okay, so what is our x? Our x is going to be 180 minus, this is actually 30, so which is 150. We convert this, it becomes 5 pi over 6. So that's our next solution, 5 pi over 6. Right. What else can we find within this range here? we'll use this one here. Okay, so sine x is equal to 1. We know that this gives us what? Positive 1. And that is going to be right here. Positive 1. Okay, so what is the reference angle? This is 90 or less. It's going to be 90. Then where else can we find sine that is positive? It's in here. But you see that if I were to look for another angle that gives me 1, the next one is this one, but it will be negative. Okay, so we can just say that now the other solution is pi over 2. So you have all your solutions there. Okay, I repeat, the first factor gave us this answer. Okay, and this one gives us pi over 6. If we check the value of sine, special angles, okay, it's within the first quadrant. So the reference angle and the angle itself are the same. So that's why we got this. Then we look for where else it'll be positive half. It'll be in here, but we use the reference angle again to get the primary angle there, which will be 5 pi over 6. Right. Then we're going to look at this one again. Okay, this one. Now we've finished all the solutions here, so we go to this one here. Sine x is equal to 1. Sine x is equal to 1 gives us 90, which is here. So we'll get this as the reference angle and also as the solution. We cannot find another sine is equal to 1 because only other one is going to be here. But that is negative 1. So that does not fit this solution. So our solutions are pi over 6, 5 pi over 6, and pi over 2 within this range, within that domain, right? Okay, so let's look at another example.